Hi, in this video we are going to see about a Python project which is entitled as Drug Recommendation System in Medical Emergencies Using Machine Learning, which is an IEEE 2023 conference paper. So before seeing the execution of the project, let me brief about this project. So nowadays it is increasing that people tend to use the internet for the medical suggestions instead of visiting the doctors. And also in some special situations like pandemic situation or floods or cyclone kind of thing, whenever the people cannot go out of the home, they use the internet to find the medical suggestion and use the drugs which is prescribed in it. But the problem with these kinds of situations is like there are various diseases available with the same symptoms. So if you are using a wrong meditation system or wrong drug, it may affect the health, and also it is dangerous to the human life also. So there are various recommendation system like movie recommendation system or a travel recommendation, but in those cases if there is any wrong, it is not an issue, you can able to rectify. But here in the drug recommendation system, if you are using some wrong drugs, it may lead to danger to our human life. So it is very important, and also there should be a scientific approach for the drug recommendation system. So in this base paper, the authors have used the machine learning model for the drug recommendation system. So here they have used the Decision Tree Classifier, logistic regression, Random Forest and Navy base, and they have achieved Decision Tree Classifier with the highest of 99.3%. And here the another problem of this base paper is like you can see they have used only few features like BP, sugar, temperature, age and condition. Based on that they are recommending the drug, but only with these features it's not possible to recommend a drug. And also here they are not predicting what kind of disease it is also. So there are various disadvantages available in the base paper. So to overcome all these issues, we are going to propose a new model. So let us see about our proposed model. So the IEEE base paper title is Drug Recommendation System in Medical Emergencies Using Machine Learning, or you can use our proposed project title Enhancing Emergency Medication Decisions with Machine Learning Based Adaptive Drug Recommendation System. So here first thing is like we have used two different models here. So first thing is like we have used Random Forest Classifier and we have achieved train score of 100% and test score of 100%. The second model that we have used is Decision Tree Classifier, and again we have achieved the accuracy score of 100% and test score of 100%. So what is the modification that we have done from the base paper to our proposed system? So the enhancement, let us list first. So first thing is like we have used Random Forest Classifier. Second thing is like we have increased the accuracy score. So even the Decision Tree Classifier, we have increased the accuracy score on it. Third point, so what we are going to do is like we are going to increase the features. Here they have used only few features, age, BP, sugar, temperature. Based on that it is cannot be able to predict. So now we are going to increase the feature. So here in our proposed system we'll be using 30 different features. So 30 different features we'll be using, and also we are going to increase the dataset records. So here we are contains about 1200 dataset records in our dataset. And also fifth point is like we'll be using 10 distinct classes of the diseases like allergy, chickenpox, chronic or cold, diabetes, fungal, GERD, jaundice, malaria, pneumonia kinds of medication conditions. So another point is that we are going to identify what type of disease it is, and we are going to recommend few drugs based on it also. So so these are the important points that we have done enhancement from the base paper. So now let us see the proposed abstract. So here you can see the proposed abstract which contains the project title which is implemented in Python, and we have used two different classification algorithm, Random Forest and Decision Tree Classifier. Second point is like you can see about the data set which contains 1200 data set records with 30 features, and you can see about the 20 distinct classes. So now let me show you the dataset and come back again to the abstract part. So in the model folder you can find this drug.csv file. So this is the data set that we are going to train up the system, which contains 30 features like itching, skin rash, nodal skin eruptions, continuous seizing, shivering, chills, stomach pain, ulcers on tongue, vomiting, cough, chest pain, yellowish, loss of appetite, abnormal pain, yellow urine, weight loss, restlessness, irregular sugar level, excessive hunger, increased appetite, high fever, headache, diarrhea, muscle pain, red spots over body, runny nose, breathlessness, fast fear heart, dark urine, prognosis. So these are the things that is available in the features part of the dataset, and if you scroll down till the end of the dataset, you can find the 1200 dataset records. So now here you may ask a question that what is the reason of having these much features. So here we are not going to use only one disease. If it is one or two disease, you can use these features like BP, sugar, temperature only, but here we are going to use multiple. It is going to predict multiple diseases and is going to recommend multiple drugs based on it. So it is going to consider various features in it. So, and also, as I said earlier, it is very sensitive. If it is something wrong, it may lead to the death of the human also. So we are going to consider this high volume data set record to make the system more effective. So here next point, coming to the abstract point back, you can see about the random forest classifier point, and you can see about the summary of the abstract. And coming to the existing system, so now we are going to consider the existing system, the base paper as the existing system. So here you can see the base paper that you have used Decision Tree Classifier with 99%, and also they have used only few set of features, and also they are not existing system has not identified the disease, and they are just recommending the drugs alone. So those details have been listed out here, and here you can see the disadvantage of the existing system. So we have listed the disadvantage of the existing system here. And coming to the proposed system, you can see about the proposed system, which is developed based on the limitation that is available in the existing system, and we have rectified those, and we have updated with all the points of the proposed system. And coming to the advantage of the proposed system, you can see the list of advantages that is available in the proposed system model. And coming to the system architecture, so here you can see the data set as the input, and we are using the pre-processing feature selection, and you can see the model random forest classifier and decision tree classifier in it. And here you can see the predicted results as name of the disease predicted, and also with the drug recommendation. So here the disease also will be shown, and also what is the drugs that is recommended for this also will be shown in the predicted results. And finally we'll be showing the performance analysis and graph part on it. And these are the system requirements with the hardware requirements and the software requirements. As mentioned, we'll be developed using Python. The version that we are using is Python 3.10.9, and the web framework we have used is Flask, and the front end part is developed using HTML, CSS and JavaScript. And this is the reference, that is the IEEE base paper reference. So before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python and the libraries installed in your system. So now let us see the execution of the project. So first go to the source code location, copy the source code location. Now go to your command prompt. First go to the drive location where you have pasted the code. In my case, I have pasted the code in F drive. So just let me go to the F drive. So now type cd space and paste the location that we have copied and click enter. So now we are into the source code location. Now type Python app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome and paste the URL that we have copied. And now you can see the home screen and welcome screen of the project with the project title drug recommendation system in medical emergencies using machine learning. So first just click this login menu. So now it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin, and then click this login button. So now you can see this login success message and click OK. So now it will be navigated to the upload part where you need to upload the data. So just select this choose file and now go to the source code location. And in the source code folder you can find this upload.csv. Just select this upload.csv and click the upload button. So now after uploading, it will be navigated to the preview part. Kindly wait till it is loading. So now you can preview the dataset that we have uploaded. So just scroll down and you can see the complete dataset has been uploaded. So now in the bottom of the page you can find this click to train or test button. Just click this click to train or test button and kindly wait for a few seconds. So now you can see the training finish message and click OK. So now it will be navigated to the important part, that is the drug recommendation part. So here you can see the features. So in the dataset you would have seen the features with zeros and one, but when coming to the user, they need to select yes or no type. So when it is 0 means it is no and yes means 1. So first question is like these are the symptoms of that the user need to enter. So it is itching or no. So I'll show you with the few cases. I'll just select no for this case. Skin rash, so defaultly everything is a no only. So whichever point you wanted you can just select. So let me select the continuous seizing as yes, shivering as yes, and chill as yes, and others let me give as no. So what are the features that is available, I'll tell you. Itching, skin rash, nodal skin eruptions, continuous sneezing, shivering, chills, stomach pain, ulcers on tongue, vomiting, cough, chest pain, yellowish on skin, loss of appetite, abdominal pain, yellow urine, weight loss, restlessness, irregular sugar level, excessive hunger, increased aptitude, high fever, headache, diarrhea, muscle pain, red spots over body, running nose, breathlessness, fast heart rate, dark urine, and model. So here in the model they can select which model they wanted and first or decision tree. So we have achieved 100% accuracy on both, so you can select whichever you wanted. So I'll show you with both the cases also. So now for this case there is only few symptoms, that is continuous shivering yes, shivering is yes, and chills yes. So others are given as no. So whichever symptoms the user is there, they will need to select only that and then click the predict button. So now let us see the prediction result. So here you can see the prediction result is allergy. It has predicted correctly, and you can see the drugs for it, that ABHECT tablet, RCAST tablet, Alsam AM tablet, Alred tablet, ARGLLA tablet. So these are the tablet that is recommended, and the model that we have selected is Random Forest. So here you can see this all now it is resetted because we are not storing the values in any database. So just it is resetted when the recommendation is shown. So first thing is like the disease is predicted here correctly. So based on that disease the drugs are recommended. So if you just copy this one drug name and let me go to the Google and type it. So now you can see abicitium, it is a combination but used to treatment of allergic symptoms. So the drugs used for the allergy is being recommended. So in this way you can also check with the other recommended tablets. So you can see the due to the allergy. So this is also an allergy tablet. So based on that we are suggesting the few drugs on the based on symptom condition. So now let us check with the other case. So just click this prediction menu again, so it will be navigated to the prediction part again. So now let me show you with the other case which contains itching as yes, skin thrash as yes, and now loss of appetite as yes, high fever as yes, and headache as yes, and other parts these are no symptoms for this. And just me check the prediction result for this case. Just click this predict button. So now you can see the predicted case. This is for this case is chicken pox. So earlier it was allergy, for this case it is chicken pox, and you can see the drugs recommendation done for it is aclovir sodium vial, valasolvir, Valtrex, Zoviraxis. So the model that we selected is Random Forest. Next time I'll select the other Decision Tree Classifier and show you. So now let us check with this drugs names. So you can see yellow fever is a symptom that is used for chicken pox. So in this way you can check with the drugs, other drugs also. So now let me go to the prediction menu again. Now let me check with the other case which contains only the weight loss, restlessness, irregular sugar level, excessive hunger, increased appetite. So for this case, we have only these symptoms. Now let us select the model as Decision Tree Classifier to show you what is the result if I select a Decision Tree Classifier and click the predict button. So now you can see the predicted result is diabetes, and the model that you selected is Decision Tree Classifier, and you can see the drugs names also. As I am not spelling correctly, I am just not telling it, just showing you. So let me select this metformin and just put in the Google and check it out. So you can see this is used for the diabetes. Let me check for this drug name. So you can check this is used for the diabetes. So now let me go to the prediction menu again to show you with the other case. So in this case, itching is available, skin rash is available, nodal skin eruption is available, and there is no other symptoms. Only these are the three symptoms available. Now let us check the prediction result for this. Now let me select Decision Tree Classifier and let's click the predict button. So now you can see the model that is selected is Decision Tree Classifier, and the disease that is predicted is fungal infection. So the predicted result class is fungal infection, and you can see the drug names here. And for sample, I'll just put this and check it out, and you can see this is used for the fungal infection. And now let me go to the prediction menu again and show you with the final case, which contains chills, and it contains cough, and it contains chest pain, and it contains high fever, and it contains breathlessness, and it contains fast heart rate. So this is the symptom of this case, and let us check the prediction result with the model Random Forest Classifier and click the predict button. So now we have selected Random Forest Classifier, and the predicted disease is pneumonia. So we have seen first case as allergy, second class as chickenpox, third as diabetes, and fourth as fungal infection. Now we can see about the pneumonia. So you can see the drugs for it, and now let me check the case of this drug. So you can see it is a drug which is used for the pneumonia. And now let me go to the prediction menu again. So in this way you can check with the other cases. So as I said, there are 10 different classes available for this. So like allergy, chickenpox, chronic, cold, diabetes, fungal, jaundice, malaria, and pneumonia. We have shown you with the few cases, so you can also check with the other cases that is available in the test and the train folder that are used for training the system. So now let me go to the next part, that is the performance analysis part. Just click the performance analysis, so you can see the performance analysis. So here you can see the performance analysis for both the model. First one is the Random Forest Classifier model, second one is the Decision Tree Classifier. So here in the performance analysis, you will be seeing the performance analysis parameter like recall value, precision value, and F1 score value. So the first one shows the Random Forest Classifier, these performance analysis for the allergy, chickenpox, chronic cold, diabetes, fungal, jaundice, malaria, pneumonia classes. And then comes the confusion matrix, which contains the true and predicted label of the case of the Random Forest. Then comes the Decision Tree Classifier. Here also we use the same performance analysis parameters, recall, precision, F1 score with the same 10 classes. And here you can see the confusion matrix with the true and predicted label of it. And final comes the chart part. So just click this chart menu, so it will be navigated to the chart part. And here you can see a chart. Kindly note that this is a static chart because we have not used any database to store the value. So this chart is being depicted from the data set that we have trained up the system. So here in the chart you can see all the 10 classes has 10% value. So here you can see 120 dataset records for allergy, 120 for chickenpox, that is 10% for the chickenpox, 120 dataset record for chronic, and 10% 120 dataset record for common cold. So there are 10 classes and each contains 120, so the total records is 1200 dataset records. So you can see common cold 10%, diabetes 10%, fungal infection 10%, GERD 10%, jaundice 10%, malaria 10%, pneumonia 10%. So the dataset record that we have used to train up the system is being depicted in a pictorial format here, and this is about the chart part. Now let me log out. And this is all about the project drug recommendation system in medical emergencies using machine learning using Python. And thank you for watching.